Imagine you're a physicist. You've spent your entire career building on one foundational assumption. Every equation you've written, every paper you've published, every conference you've attended, all of it rests on a single idea. The universe began with the Big Bang. Now imagine a colleague slides a paper across the table. New data, new observations, and the numbers don't fit. Not slightly off. Not a rounding error. Fundamentally, irreconcilably broken. This is not a hypothetical. This is happening right now, inside the most prestigious physics institutions on Earth. And the question being whispered in hallways, the one nobody wants to say out loud, is genuinely terrifying. What if the Big Bang, the story we've told ourselves about the birth of everything, is wrong? Let's start with what we actually know. The Big Bang model says the universe began approximately 13.8 billion years ago. It was infinitely hot, infinitely dense, and it expanded. It cooled. Matter formed, then stars, then galaxies, then you. It's elegant. It's mathematically beautiful. And for decades it fit the data almost perfectly. Almost. The first crack appeared quietly. Astronomers noticed that the universe was expanding. Not just expanding, but accelerating. Something was pushing galaxies apart faster than gravity should allow. They named it dark energy. It makes up roughly 68% of everything in the universe. And here's the unsettling part. Nobody knows what it is. We gave it a name and called it understood. It's not understood. It's a placeholder for our ignorance dressed up in scientific language. But dark energy is old news. Scientists have learned to live with it, the way you learn to live with a strange sound your car makes that no mechanic can explain. Uncomfortable but manageable. What's happening now is different. In 2023 and 2024, the James Webb Space Telescope started returning images that should not exist. Galaxies. Fully formed, mature, massive galaxies, appearing in a period of cosmic history where the Big Bang model says they couldn't possibly be there yet. These galaxies look old, structurally complex, evolved. But according to our timeline, the universe at that point was barely a few 100 million years old. There wasn't enough time for these galaxies to form, not even close. Astronomers called them impossibly early galaxies. That phrase alone should give you pause. When scientists use the word impossible to describe something they've directly observed, something has gone deeply wrong with the model. And this is where the story stops being about telescope data and starts being about something much more fundamental. The Big Bang model doesn't just tell us when the universe started. It tells us how structure forms, how matter clumps, how long it takes gravity to pull gas clouds into stars and stars into galaxies. The entire scaffolding of modern cosmology is built on that timeline. These Webb observations aren't a small anomaly you patch with a revised constant. They cut directly at the foundation. Some cosmologists are responding cautiously. They suggest tweaks. Perhaps star formation in the early universe was more efficient than we modeled. Perhaps dark matter behaves differently at early epochs. These are reasonable scientific responses. Adjust the parameters. Save the model. But a growing number of physicists are saying something more radical. They're pointing to a deeper problem, one that has lived in the shadows of theoretical physics for decades. The Big Bang model requires something called inflation, a period of impossibly rapid expansion in the universe's first fraction of a second. So fast it violates what we normally understand about how things can move and expand. Inflation was invented to solve problems with the original Big Bang model. It explains why the universe looks so uniform in all directions. It explains the flatness of space-time. But here's what the textbooks don't emphasize enough. Inflation has never been directly observed. It's a theoretical mechanism inserted to make the math work. And the predictions it makes, the specific gravitational wave signature it should have left in the cosmic microwave background, haven't been confirmed despite decades of searching. We built a model on top of another model, and we called it a theory of everything. Now, zoom out further. Because there's a physicist named Roger Penrose, Nobel Prize winner, one of the most respected minds in modern physics, who has proposed something that makes inflation look conservative. His theory is called conformal cyclic cosmology. The idea is that our Big Bang wasn't the beginning of time. It was the end of a previous universe. That the universe doesn't begin and end. It cycles. Each Big Bang is the rebirth of a cosmos that came before. Penrose claims he's found evidence for this in the cosmic microwave background, faint circular patterns, echoes of black hole collisions from a previous cosmic cycle, bleeding through into ours. The scientific establishment has pushed back. Hard. Other researchers argue the patterns are statistical noise, that Penrose is seeing shapes in randomness the way humans see faces in clouds. The debate is unresolved, and that unresolved status is itself the point. If the most decorated cosmologists on Earth are genuinely publicly disagreeing about whether our universe has a previous universe baked into its oldest light, then the confidence with which we teach the Big Bang in schools deserves serious scrutiny. But here's what makes this truly disorienting. The Big Bang isn't just a scientific model. It's the creation story of the secular world. It's the answer to the oldest question a human being can ask. Where did everything come from? For generations, it's been the bedrock. Settled? Done. Move on. And science works because it can revise itself. That's its greatest strength. But revision at this scale, revision of the origin story, doesn't feel like a normal update to a parameter. It feels like pulling a thread from a sweater and watching the whole thing unravel. Because if the timeline is wrong, then our age of the universe is wrong. If our age is wrong, then our understanding of stellar evolution needs revision. If that goes, so does our model of how planets form, how life emerges, how long complex chemistry has had to work in a given system. The whole chain depends on that foundational number. 13.8 billion years. 4 digits. The entire history of everything compressed into a figure we engrave on museum walls and put in children's textbooks. What if it's wrong? Here's what we can say with confidence. The universe is real. It's old. It expanded from a hot, dense state. The cosmic microwave background is real. The evidence for something like a Big Bang is overwhelming. Nobody credible is suggesting the universe didn't start somehow. What's genuinely in dispute is the precision, the completeness, and the mechanisms of our model. The timeline is shakier than it was 5 years ago. The formation of early structure is not well explained. The nature of the energy-driving expansion is entirely unknown. And the very first moments of the universe remain completely untestable, hidden behind a mathematical wall called the Planck time, where our equations simply break down and give us nonsense. We have looked further into the universe than any humans in history, using the most sensitive instrument ever built, and what we found wasn't confirmation. It was questions. The universe is 13.8 billion years old, give or take an entire crisis in cosmology. It began with a bang, except possibly a cycle, or a bounce, or an emergence from a prior state we can't currently describe. The first stars formed when they were supposed to, except for all the ones that didn't. We didn't find the edge of the universe with James Webb. We found the edge of our model, and beyond that edge, nobody knows what's there.